Hello and welcome to an episode of Today You Learned, this time on an analysis of a CTF malware sample. So the malware sample, let's dive right into it, of course, let's move on to here, is actually this one, right? Badransomware.docim. It's from the HackTheBox CTF from 2021, and it has this checksum, so you can find it online. It's pretty easy to find in different malware analysis platforms, or you can contact me if you want. So as based on the extension and of course the file command, it looks like it's a Microsoft Word 2007, and it probably has macros, right? Since we see the extension as being docm. Since it has macros, one way would be to open it into Word and then look at the macros and see what is happening right there. That's one way of doing it. I tend to do things sometimes a bit differently. And one tool that I would actually like to use to show to you how you can also solve this sample is this tool, which you quickly saw a minute ago and which I already previewed earlier on this channel. It's called Binary Refinery, which is actually a collection of Python scripts, 300 to be correctly, that perform transformations of all kind of data. It does encryption, decryption, exportation, carving, data carving, decoding, replacing, substituting, and so on and so on. It's actually CyberChef, which you might know from other CTF. There's not a lot of CTF challenges that you can do without CyberChef, I think. So it's like CyberChef on the command line, and it has a lot of options. It actually has a very neat help web page where you can actually see all the commands that are implemented to use. It's fully written in Python, which means that it works equally well on Linux as on Windows, which is actually the biggest plus that I have for me, because I always switch between Linux and Windows, and it's fun to have something that works equally well on both. Okay, so if we try to cat this like this, then of course we have all kind of strange data right here. So the other option of cat, so the one that is built into Binary Refinery, would be emit, right? But in this case, it does not really help. So let's try it a different way. So let's take a look. What can we do? Since it's probably one that has macros, let's find out if there is an option to have macros from Word documents. Hold on. So let's take a look. What else do we have? I already know which is it's written in VBA, right? If we look for macros, there's too much options for macros. Macros are written in VBA. So this is the one I was looking for. It's a class VBAPC, which actually extracts the macro code from Office documents. Looks exactly what we want, right? It also has a VBA extract macro strings from Office documents. Okay, if this fails, then VBA str could be useful. So let's try VBA PC first. So VBA PC, let's put it at the top. Notice that we of course need to feed it the Word document, otherwise it will not help. And what do we get back? We get the exact macro that is actually in here. Let's bind it into less to show you. So we have our decompiled stream, which is a declare, or which has a declare. It performs a lot of sleeps. Sleep 0, which means it's just for the obfuscation there, so that serves no purpose. It's just to letting the kernel know that it has to sleep for 0 milliseconds, which is of course stupid. It also has like these double declarations of a parameter that is then being put or declared or initialized, I should say, as 3-digit numbers, and also some tangents on that to be put in the other one. So if we want to work on this, it would be useful, because there does look to be some other stuff as well, of course. It would be useful just to remove these sleeps. So luckily for us, you can do that in the Binary Refinery, or you can of course just move it out of the way using grep. So grep like this. So now we would be losing the sleeps. It's already a lot shorter. So now we have the sleeps no more. And if we take a look, then we see that this actually does not do anything. The OSMUX is never used again. So again, this is just to obfuscate stuff. We see the same system right here, two variables, then one is declared and the other is used for tangents, operations, and so on. So maybe another thing we want to do is to grab out everything that has ton in it, right, like this. So it will be already a little bit shorter. Maybe we can also grab out the 3 digits. For that we might want to use a regular expression. So it would look like this. So 3 digits. Where did I make my typo? Oh, of course, like this. So now he has removed all the initializations into 3 digits. This could be useful because this one is actually being used here in a split operation, so this does not really seem to be bogus. But we already know that this is probably bogus, so let's grab that out as well. Another way, or one way to do that would be to do it like this. So if it starts with dim and then it has like a 10 digit, because it's always 10 digits, and then comma, and then another one like this, also 10 digits. Grab that out, then it looks like this. So this is already a lot better to look at. So what do we see here? We see that we have like a shape from the document that has a specific ID that seems to have an alternative text put into a variable, concatenated with another shape. So we have 2 texts that are coming from the document put into here, and then it seems to be split based on the @@@, and then other stuff is being done with it. Eventually we see something like POWR, so this is PowerShell, an encoded payload it looks like, and the payload has IAB at the front, and then it's followed by the ones that are seemingly coming from the document, right? U-bound, I already know, has it means upper bound, which is just the length of this array. So this array, that is actually the array from the split right here, is being put as a variable or an integer variable right here, which is then looped through to put it all into a single variable. Okay, so what we do need now is to have a look at this, the alternative text, and it seems like this one is first, and then it's concatenated without anything in between with the second one, the one from PELXC. So maybe it's a good idea to open up a new one so I don't lose this this code. So we have our bad ransomware. So is there a way in Binary Refinery to find out, to extract some documents? So to extract some data from documents, from Word files? Well, so extract text from Word, okay, could be useful, but maybe there's another one. And this extract files from a document such as a Microsoft Word. This seems to be much more interesting, right? Extract files from a document. Okay, let's see if this has something to do or something that helps. So let's emit this one like this. Extract doc, and then we can see that it seems to have worked. We have some XML data. Maybe it's a good idea to put it into a less to have some views like this. So here we have our XML data, which is actually what every Word or Excel file is created upon right currently with the docx and so on. And then right here we see something like a doc program with an ID, and it has the name PELXCITRDD, which is one of the variables that we saw right here. And then it needs the alternative text. And then here we have our description, so this is that alternative text. So the PELX seems to be very large. It starts with a 4, and then we see that it is delimited with triple ats. For some reason that same file is in here another time, so it's in here 2 times. And if we look further, we have our other one, ADA, and so on, which is the second one, right? So this one is also needed. This one starts with 74, and then it ends a lot longer, so it's a lot longer. So page down. Okay, too long to see. So this is the longer one of the two, and the longer one is actually the first part, and then the other one is concatenated after the first one. Okay, so we need to get this long string out of that file, right? So we already have it with the extraction option, so maybe we can grab on it. So let's grab on, for example, this one. Okay, we already have some better information right here. Maybe it's a good idea to now carve it out. So carve means we filter, or we try to get the strings out. So carve is actually to extract certain types of data, for example, integers, strings, letters, base 64 stuff, which is interesting. So in this case, it's just ASCII. So let's see if we can do it something like this. Okay, so if I sort it into length, because we can sort it by longest, and we only take the two longest ones, and maybe ignore or yield every much only once. So Q would be also another one, and then we maybe want to do it like this. Then we see that we have our first one that starts with 4, and then we have our second one that starts with 74. So the longest one is actually right here, and then 74 is right here. Okay, so we have our two long strings that we need to concatenate. There are different ways of doing this, but maybe it's the most useful one. Actually, we can have them have a better view if we do it like this. So now we can see that we have our two different files right here with peak. The first one is the shorter one, this one is the longer one. So let's maybe start with the first one. Right, so this is the first one, and then this seems to be the first one that we need. Let's also remove the double quote at the start and probably at the end as well. So replace double quote like this. See if this has helped. Yes, double quote has gone. So now we can put that into data.txt. Okay, is that okay? Let's look at data.txt. Seems to be fine. So this was the first one. Now we need a second, or the second one, which is a little bit shorter, of course, 6.5. So then the max would be something like this. Let's take a look. Is this the second one? Yes. This also has the double quote, so replace like this. See if this has worked. Yes. So now we can add it to data.txt. So if I now take a look, this seems to be fine. Seems to be fine. So now we have our data. Now we can try to actually reconstruct the integer array, or at least the array, by splitting it on the three double adds, and then reconstructing an array that is into a file. There's also a very useful command for that in Binary Refinery, and it's called pack. Let me find out pack right here. Bcap is also interesting, but this is pack. So this scans for constants and put them into a binary format. So for example, if it looks like this, he would transform it into the hex format, which we can of course use further. So the delimiters that is here is a comma, but he will automatically try to detect the used delimiters. So let's see if he finds out that the triple adds are actually the delimiters. So if I do it like this, this seems to be base 64. If I peek into everything, we can even see that it ends with an equal sign. The X is something that is still left over. So it looks like the pack has actually worked. And then if we go back, so this would be what is inside this variable, right? We already split it into triple add, and then we converted it back into a long string, and then that string is actually sent to PowerShell, but of course it needs to be prepended with IAB. So this is base 64. So if we would try to B64, if we would try to decrypt it it will not work because it actually needs the first 3 bytes. So how can we do that? There are different ways. We can of course just open data.txt and work with that, but that's not the easiest one. So what I can do is actually do a replace, for example, of this one. Replace IAB, let's verify IAB, and then of course this one. If I now look again, then I see that my IAB is actually being appended here. So if I now try to decode it, then I think it works, right? So this is the base64 decoded data that is actually being fed to PowerShell. So this is, now we are moving into PowerShell, right? From the macro to PowerShell. So here we see that there is actually a join with a split. So the split is the split means, so PowerShell split means that it needs to split this array based on either of these characters, right? It's not, this entire string is not a single character or a single string to use as a delimiter. Any of the strings inside this, any of the characters inside this string has to be used as a delimiter. So in other words, this is the end of the first one, this is the end of the second one, this is the delimiter, next portion of the delimiter, and so on and so on. So how can we do that here? Well, there's actually an option for that. It's called a regular expression split, which is also in the Binary Refinery. If we look at split, we can see in the options right here that split is not really an option. There's no split, but there is an RE split, which means regular expression split, which makes it a little bit easier for us, because this means that we can actually just do something like this. And now we need to add pipe signs, because if I try it out like this, he will try to split on this entire string, which is not what we want, of course. Like this. So now if I peek it, it looks like it has indeed split it, I believe. So let's maybe just do it like this. Okay, it has worked, but I actually forgot something, because I of course only need to split this entire string, not the entire file. So we'll first have to carve the string itself, and I only want the longest string, which would be like this. So now we have this one, and now here we can actually perform our RE split, right? Carve string -s. So this looks better right here. Okay, so now we can try to, well, we can also try to replace the single quotes at the beginning and the end. So that looks like this. Quotes are gone. And now we can try to convert this back into a hex array. But I did notice that there might be an issue here, and I think it's more or less like a bug inside the environment, inside Binary Refinery. But I found a solution. So the problem here is if I dump it to a temp file, temp file, or write it to a temp file, like this, temp file. If I cut it out, it looks fine. If I VI it, we notice that there are extra characters in between. And this is why the pack does not work, because the pack notices the new lines, which is okay, but he fails on these little @ signs. So instead of splitting using the split module, we can actually use a substitute module. So with sub, which is also an option right here, it's actually right below it, substitutions. So we can substitute these delimiters by a single delimiter, a random one. For example, the comma one, right? So if I look at how this looks like, this now becomes our new array. So, and this will be someone or an array that we can use our pack on. Of course, we need to specify, well, we need to replace the first one. Hold on. We need to replace the quotes at the end. So if I do it like this, we have removed the quotes, and now it should be better or not. Let's take a look. Temp file, put it into the temp file, temp file. The ats are still here, so that's not good. It's actually, if I do it like here, we can actually see the little odds, which are actually null bytes. So we need to remove the null bytes first before we are able to unpack this this long string, right? So this is an option. So the replace option is not that important, but to substitute, we can actually replace, and we want to replace the null byte, and now let's take a look. This looks better, right? So without that replace, I don't need to write it to a file to see it. We can see it like this. So this would probably be better. So if I take a look again, this is how it looks like now. So if I now try to pack, we actually get the data that we need to get back. So this is a bit harder to perform. We also see that there are a lot of strings that are being concatenated with a plus right here. So we can also actually perform another replace on that. Replace, oh, the pack is required, of course. Replace, like this. So now we can see load file invoke, and then we see some, we can try to read this out because we're actually at the end of the exercise right now. So we can see that a lot of arrays are being, well, read and invoked, and right here we see actually a 64 base 64 string that is being created. So maybe it's an idea to try to decode this base 64 string because it's a DRT. So it could be your key, and it could be a useful one to find out. So the first one would be SF. The next one would be this one, RCE3. This is something that I'm not sure, don't think can be done with Binary Refinery. So the next one is 2, which is the I. Then the next one is this one. Then the F1, and of course Q equals is probably the last one. And if we do that, we can actually see the flag from last year. Okay, I hope you learned something and keep learning.